In this video, we find the Fourier transform of the function f of t equals u of t, where u of t is called the Heaviside function or the unit step function. We take the definition of the Fourier transform. We use this hat notation, which is the integral from minus infinity to infinity of the function f of t times e to the minus I omega t dt, where omega is greater than 0. We split the integral into two parts, from minus infinity to 0 and from 0 to infinity, plus the integral from 0 to infinity f of t e to the minus I omega t dt. From minus infinity to 0, the function is equal to 0, and we only have this integral, the integral from 0 to infinity. From 0 to infinity, the function is constant, is 1, and here we just write e to the minus I omega t dt. We can find this integral explicitly is e to the minus I omega t divided by minus I omega minus 1 divided by I omega. This term, when t grows to infinity, this term goes to 0, and for t equal to 0, this is just 1, and we get that this is equal to 1 divided by I omega. So the Fourier transform of the unit step function is 1 divided by I omega, or we can write it as minus I divided by omega by multiplying with a conjugate complex number. So this is, we can write it as f of I omega equals minus I divided by omega. Which is a complex quantity. This function is a complex valued function. Now, what is the modulus? The modulus is the modulus of this complex number, which is the square root of the real part of the complex number squared plus the imaginary part squared. And this gives me 1 divided by the absolute value of omega, and because omega is strictly positive, we have 1 divided by omega. The function f would denote f of omega is the modulus of the function f of I omega, and this is 1 divided by omega. Let's take the limit of this function as omega growing to infinity. As omega grows to infinity, this one tends to 0. And what is the property? So it goes to 0 as omega goes to infinity. F prime of omega equals the derivative of f with respect to omega, which is the derivative of 1 divided by omega, and this is minus 1 over omega squared, which is negative. So f is a decreasing function for omega belonging to 0 infinity.